Download this code from codegive.com, link in the description below. Certainly. When working with APIs or web services, rate limiting is a common concern. Many APIs enforce limits on how many requests you can make in a given time frame, example 100 requests per hour. If you exceed these limits, you might receive errors or even get temporarily banned from making requests. Using asyncio in Python allows you to manage asynchronous tasks easily, and combining it with a rate limiting mechanism can help you stay within those limits. The following tutorial will guide you through implementing a simple rate limiting mechanism using asyncio in Python. Tutorial: Staying just under rate limits with asyncio. Step 1. Install required libraries. You may need to install the aiohttp library to handle asynchronous HTTP requests. You can do this using pip bash pip install aiohttp. Step 2. Define rate limiting logic. You can create a simple rate limiter using a coroutine that manages the timing of requests. The idea is to ensure that requests are spaced out appropriately so that you do not exceed the allowed rate. Step 3. Implement the code. Here's an example code snippet that demonstrates how to implement a rate limiter with async/await. Python. Import asyncio. Import aiohttp. Import time. Class rate limiter. Def__init__, self, rate_limit, int, per_seconds, int. Self.rate_limit equals rate_limit. Self.per_seconds equals per_seconds. Self.last_request_time equals 0. Self.lock equals asyncio.lock. Async def wait, self. Async with self.lock. Current_time equals time.time. Elapsed_time equals current_time, self.last_request_time. Calculate the time to wait. If elapsed_time self.per_seconds/self.rate_limit. Wait_time equals self.per_seconds/self.rate_limit, elapsed_time. Await asyncio.sleep, wait_time. Self.last_request_time equals time.time. Async def fetch, session, URL. Async with session.get, URL, as response. Return await response.text. Async def main, URLs. Rate_limiter equals rate limiter, rate_limit equals 5, per_seconds equals 1, 5 requests per second. Async with aiohttp.client session, as session. Tasks equals. For URL in URLs. Await rate_limiter.wait, wait before making a request. Tasks.append, fetch, session, URL. Responses equals await asyncio.gather, * tasks. For response in responses. Print, response 100, print first 100 characters of each response. If __name__ equals __main__. URLs equals https://hpbin.org/get for _ in range, 20, example URLs. Asyncio.run, main, URLs. Breakdown of the code. 1. Rate limiter class. This class manages the rate limiting logic. It takes in a rate_limit, the number of requests, and per_seconds, the time frame in seconds. The wait method ensures that requests are made according to the specified limits. 2. Fetch function. This function makes an asynchronous GET request to a given URL using aiohttp. 3. Main function. This is the main entry point for your asynchronous tasks. It creates a list of tasks to fetch the URLs while respecting the rate limits. For running the code, the script creates multiple requests in a loop and uses the await rate_limiter.wait call to pause as needed before making each request. Conclusion. This implementation allows you to stay just under API rate limits while making asynchronous requests using asyncio. You can adjust the rate_limit and per_seconds parameters in the rate limiter class to fit your requirements. Just remember that different APIs have different rate limits, so always check the API documentation to configure your rate limiter correctly.